Okay, 2023 paper 2, question 7F. So Olga's breathing is also measured when she's doing gentle exercise. During this time, when she breathes in fully, the volume of air in her lungs is 3.6 liters. And when she breathes out fully, the volume in her lungs is 1.3 liters. When she breathes in and out twice as many times per minute as when she is resting. Use this information to write the formula for the volume of air in Olga's lungs during this time, t seconds after she has breathed out fully. Give your answer in this form. Okay, so we're using the same basic idea. It's when she's breathing out. So we're going to have the same shape graph. So we're going to have a value for A. We're going to have minus a value for B. And we're going to have cos. And we're going to obviously have a value here as well. So when she breathes in fully, it's 3.6. So hopefully you'd agree the very, very highest we can get is 3.6. So at most, she can get 3.6 liters into her lungs. If she takes the deepest breath, she can. Now, when she breathes out, our lungs, of course, are never empty of air. Otherwise they'd collapse. So there is actually still 1 liter, 1.3 liters in her lungs when she fully breathes out. So hopefully it makes sense that what I can find is the difference between these two numbers. So using my calculator, I'm just getting the difference. So I'm doing 3.6 minus 1.3. Now that gives me 2.3. So there's 2.3 liters difference between a full lungs and a one where she's after breathing out. Now, what I'm interested in, of course, is the midline and the amplitude. So what I'm going to do next is I'm going to say, well, what is half of 2.3? Now, I'm interested in half because that will tell me the halfway point. Well, it'll tell me actually halfway would be 1.15 here, and of course 1.15 here. So it's like splitting the 2.3 into two pieces, 1.5, 1.5. So that's my amplitude. So what's my midway line? Well, the midway line is, you can say it in two different ways. You can say it's either 1.5 liters below 3.6, or you can say it's 1.5 liters above 1.3. Now you'll get the same answer. So let's try both ways. So we'll still show our working. So I'm going to do 3.6 minus 1.5. So that gives me 3.6 minus 1.5. No, 1.15, sorry, 1.15. I knew I'd done something there. Yeah, so, yeah, there was something with those figures. So sorry, 1.15 and 1.15. Okay, back on track. So, yeah, so I'm taking 1 point, and that should be a 1.5 in the answer. So I'm taking away from 3.6, I'm taking away 1.15. Okay, so let's take that away. 3.6 minus 1.15. So that's giving me 2.45. So 2.45 should be my midway line. Now I'm going to check that by also doing it the other way. So I'm typing in 1.3 and I am adding on 1.15, because remember the amplitude is the difference between the midline and the very minimum or the very maximum. So I get 2.45. So that confirms to me that the midline is definitely 2.45. So I fill that into where my midline would be on my function, 2.45. Now I've only one more job to do, and that is the period. Now, we are told that she is breathing twice. She breathes in and out twice as many times. Now, twice as many times. So think about what the period used to be. So the period was pi over 2t. That's correct, isn't it? Let me double check. Pi over 2t. Now, if she's doing it twice as fast, we will multiply by 2. And that actually just gives us pi t. So the period is now pi t. Okay, and that's the answer to that one.